It is my honor to present a $1,000 check and a trophy to the team from Wayne State University.
The value is there for the students' sake. We get to look at real-world problems, real-world technology. You know, we're doing research. The value for the students' experience, learning experience, is definitely there, and it's well worth it.
They're in a lab. I mean, they're given a car, the same car that other universities have, and they've got to redesign it. They've got to reconfigure the engine. They've got to figure out what kind of compression they're using. They've got to figure out all of the technical aspects of using this fuel, which burns differently than a traditional petroleum-based product. So it is a very challenging academic exercise.
The experience that I got from this competition will definitely help me in teamwork aspects as well as innovative design thinking and the approach to a real-world problem.
September 1997, Paul Nehra, a mechanical engineering student at Wayne State University in Detroit, and a few of his close classmates find themselves at the beginning of an arduous journey. Their goal? To build an alternative fueled car in less than 9 months. A competition-ready car that could seize a national title at the 1998 Ethanol Vehicle Challenge. After waiting anxiously over the summer, the students and their faculty advisor, Professor Dinu Terraza, learned their proposal was approved by the U.S. Department of Energy. They are one of 14 schools and universities across the United States and Canada to compete on Memorial Day 1998. They face the daunting task of re-engineering a 1997 Chevy Malibu to run efficiently on a blend of ethanol, an alcohol made from corn.
Yeah, it's like square root. It's a square root.
As rookie engineers, they are motivated by the challenge of working with the new technology, as well as the idea their efforts could actually improve on it and someday result in the contribution to a cleaner environment.
From the beginning, we really looked at ethanol as a challenge because we really didn't know the properties of ethanol. That was one of the biggest things we had to understand.
And there was a lot of issues that we didn't know of because most of us had been involved in alternative fuel. So it was at this time that we learned, corn-based fuel, we learned cleaner emissions and these kinds of things.
The major differences between the gasoline and the ethanol are that ethanol is much more corrosive than the gasoline. And the second one is that the octane number of the ethanol, it's much higher than the gasoline one. The ethanol has around 110, 120 octane number, and the gasoline, it's usually between 87 and 94 at most.
It's a renewable resource. As opposed to gasoline, it's something that we don't know when it's going to run out. We have an idea, but with ethanol, it comes from biomass, things like corn, so it can be reproduced, so it's something that's not going to run out.
From the initial small group, Team Ethanol has grown to a solid core of 10 team members. Paul Nehra proves to be a knowledgeable and resourceful leader of the group.
I'd like to tell you from the very beginning that I was very happy with this student team. They have been from the very first time very enthusiastic about this project.
Well, I first became a part of the team. Paul Nehra called me and approached me. He wanted to do, it was our senior year, he wanted to do some type of project that was not just theory, that applied what you learned and do some hands-on experience. working on things, and he knew of this competition, this ethanol vehicle challenge.
He was the captain of the team, selected by the team members. Originally, we was kind of hesitant to pick a team captain, but when the competition got started, we all unanimously elected Paul as the captain, and that was for the knowledge that he had.
From the outset, Team Ethanol faces several major technical challenges. The properties of ethanol require that it vaporize at very high temperatures, making it difficult to ignite at below 30 degrees Fahrenheit. Just as significant is the task of incorporating the necessary modifications without sacrificing fuel economy and performance.
One of the biggest things we had to cover was cold start, because of the properties of ethanol, it's harder to start in colder temperatures than it is for gasoline, and that's a major concern.
We knew we had to address issues like cold starting and emissions, so knowing these things in advance, we sat down, we went through design processes, went through iterations.
And what we came up with was a heater system for that cold start. Our cold starting device has been inspired by something that's used on diesel engines that we saw at a exposition for a certain company. So it's definitely helped us, and from their design, we made our own design.
Memorial Day 1998, opening day of the 1998 Ethanol Vehicle Challenge. General Motors Corporation Proving Ground, Milford, Michigan. After working long hours in the lab the past 9 months at the expense of their personal schedules, after successful road testing around campus, Team Ethanol members are buoyant about their chances for a good performance and ready to grab their ultimate goal, first place. But just before the first event, as dignitaries stride up to the podium to make their speeches, Team Ethanol is in trouble.
The most intense moment of the competition was the first day, actually. We had a fire, electrical fire.
Our car was parked in the pit area, and we went to go start the vehicle to pull it out and get it in line for the opening ceremonies. And I was standing in front of the car, and Paul Nera turned on the vehicle.
We had a fuse that actually blew on us, and it caused a fire. And basically our whole heating system was ruined on day one, and this was right before the competition actually started.
No damage to the actual vehicle except to our heater system. So at that point, we had to sit through the opening ceremonies, knowing that right after the opening ceremonies were completed, we had to put back together our entire heater system.
And we had a spare one, but this is the one that we had used in testing, so we didn't know if it was really ready to put on the car, but we had to go with it because that was the only one we had left.
And we had to do it in a short amount of time. And the churning and the tenseness, built up because you wanted to get it fixed right away. Something happens, you want to get it ready, so you can compete the next day. And it was extremely, extremely tense.
It left the team really uncomfortable with the decision that we made, but at the same time we felt good enough about what we was doing that we could pull this thing off, and we did.
The team members knew they performed well. In the performance events, drivers John Auld and Jeff Woodkey reached 83 miles per hour in car number 9 in just 16 seconds, the fastest time of all competitors. The Wayne State car also achieved 29.2 miles per gallon highway driving, although the team did not learn of this until 3 days after the final event. In fact, all the teams had to bite their nails until the final results were calculated and revealed at a special ceremony in Washington, D.C. There, officials announced that Team Ethanol accumulated 797 points out of a possible 1,000 and a first-place finish.
I just remember being at the awards ceremony, and they were naming off the top 5 teams, and they kept counting down, and they came to the second team, and I thought, well, maybe we got second place. And then they named the second place team, and they said it was Waterloo. And they came to the first place team, and there were still doubts in my mind.
And then when it came down to the last 2, it was just, I knew we'd won, and it was no other feeling like it. It was really special to me.
And it was a great sense of pride that went through all of us. Very, very exciting time.
When they called Wayne State out, everyone jumped up from the tables. We all started giving high fives, and it was just great. It was a feeling that I'll cherish forever.
From this experience, I think I can
take this into my place in the workforce and be that much more of an impact at where I am at my job.
As young engineers, to get that hands-on experience early is very important.
When I came into this project, I had very little automotive experience, and now I'm working on future vehicles of 2000, 2002.
Do I look forward to a career in this field? I can't wait. I've recently graduated, beginning working in this industry in about 2 weeks, so I'm really looking forward to it.
You demonstrated that you can do this. And a matter of fact, the winning team had a fuel baseline 20% better than a conventional counterpart.
The most important thing is I'd like to encourage Wayne State University to keep projects like this alive and to encourage students to get involved in these projects.
It gives us a great opportunity to work with the excitement and the creativity of students in engineering, to see all their wonderful ideas come to fruition and to test them out on the road. And then we can take those ideas into our research and development and see which ones will prove out in the end. So it's a great opportunity for us to connect with the universities, to be a part of a program to explore new technologies for the automotive industry.
The Ethanol Vehicle Challenge is a terrific way to show that ethanol can perform as well or better than the conventional counterparts. Many of these students are going to go on to take jobs in the auto industry, and they're going to bring with them an enthusiasm and an understanding for alternative fueled vehicles that perhaps wasn't there before. So in a sense, we're really building more than just vehicles, we're building engineers.
We discussed from our first meeting that we don't want to just do the job. We want to be first.